Well, good day to everybody. I'm going to cover something that's come up with a couple of my students in the last couple days having to do with horizontal asymptotes. Many of us learned horizontal asymptotes in terms of how to deal with um, how to get horizontal asymptotes when we're talking about polynomials in a rational function. That is, when the numerator and the denominator are both polynomials, where you consider the degree tests. Well, for this kind of example, this isn't really quite as applicable. So as a result, we want to use the limits approach. And it's always good practice to practice your limits. So let's go over this example. It's going to be fairly quick, but here is the lay of the land here. We have to consider the limit as x approaches in positive infinity as well as negative infinity. So let's take this function here and let's take it from the approach of as x approaches positive infinity. Now I'm going to deal with this part of it in two ways. The first way, I'm going to look at this denominator, and as x approaches infinity, e to the x approaches infinity. That should be clear. Now the minus 6 can be dropped off. It's an insignificant term. So therefore, the e to the x minus x can be reduced to e to the x in the sense of limit analysis. And therefore, now we have a pretty easy problem because the e to the x over the e to the x cancel, and we have the limit as x approaches positive infinity is positive 7. Okay, too many times students forget to deal with the negative infinity part of the equation. And this is a great example why that is important. So let's look at the same function and let's address it. I'm sorry, it's down here. Let's address this from the standpoint as x approaches negative infinity. Now you have to make sure you understand very, very well the concept of negative exponents. So we want the limit here, which is the original problem, but as x approaches negative infinity. So now don't overthink this. Keep it as simple as you can. But as x is approaching negative infinity, you kind of have to flip your thinking a little bit. What's happening to e to the x as x is approaching negative infinity? I always recommend using test points if you're hitting a roadblock. So if we were to do that and look at what happens as x goes from -1 to -10 to -1,000, etc., well, what's happening to e to the x? Well, that's 1 over e, 1 over e to the 10, 1 over e to the 1,000. Clearly, this sequence is approaching 0. Too many times we've got it stuck in our head to use the e over x is approaching infinity, so 1 over that approaches 0. It's not the case here. E to the x approaches 0 as x approaches negative infinity. So now our problem is actually fairly simple. Our limit as x approaches negative infinity is going to be 7 times 0 divided by 0 minus 6, which is 0 over -6, which is 0, which is in fact true. The limit as x approaches negative infinity of this function is 0. So yes, you clearly can have two different horizontal asymptotes. And if that causes you some grief, think about it this way. The horizontal asymptotes are nothing more than a representation of what's happening with end behavior. If you remember when you studied end behavior with polynomials, you clearly remember as x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y goes to negative infinity. So the limits can be two separate things and is a representation of what's really happening. Send me any comments and give me some questions over some other topics you want to see gone over. Take care.